For the past couple of videos, we've talked about ionization of weak acids. In this video, we are going to be talking about ionization of weak bases. Honestly, the basic concept for both of them is going to be the same. It's just that we're talking about bases and acids. And in case of bases, we'll be talking about the OH minus ion. In case of acids, we will be talking about the H3O plus or the H plus ion. So the basic concept is the same. So if you want like a detailed explanation, I would definitely suggest you that you check out the previous like the video related to the ionization of the weak acids. Okay, and I know those numericals are pretty long, so definitely check them out. So ionization of weak bases. So basically when you have a base, let's assume we have a base MOH and it's in water. Okay, so we're also as so this if excuse me, this in water will be in equilibrium to give us M plus plus OH minus. Okay, we care about the OH minus ion now. So the initial concentration, as we did it for the previous time, so the initial concentration, let's assume, of the base is C. Okay, it's represented by C. During the change in concentration will be minus C alpha. Okay, the reason we're saying C alpha is because C is the concentration, alpha is the degree of ionization. Okay, alpha is the degree of ionization. So there is a decrease in concentration by C into alpha. The next one is increase in concentration, obviously, because there is going to be an increase in concentration of M plus. And similarly, you'll have an increase in concentration of OH minus by C plus, C alpha. So at equilibrium, the concentration would be C minus C alpha for MOH. Okay, initial minus the change. And this one would have been 0 and 0. And then so you have C alpha and C alpha. I know if you watch that video, it's basically what we discussed in that one, right? It's the same thing, only difference we're talking about bases now. So here you would have the value of K. K for this equation will be M plus, concentration of M plus into concentration of OH minus. And at this point, I'm going to assume you know how to write the equilibrium equation, right? So H2O into the concentration of MOH. And similar to what we did for acids, this is in a higher quantity. So K into H2, concentration of H2O will be equal to Kb. That's the only difference. Okay, here it is Kb. So this is the base ionization constant. Okay, so this is the base ionization constant. Okay, so Kb will be equal to concentration of M plus into concentration of OH minus divided by concentration of MOH. Okay, so this again you have C alpha into C alpha all divided by C into 1 minus alpha. Cancelling the value of C, so you have C alpha squared divided by 1 minus alpha. Okay, so basically the KB values, if you've noticed, or rather in the table that has been given, you have the various KB values. I guess I could have copy pasted it. Oh well. So they are all the amines. Notice the amines, right? The amines are actually weak bases. And basically, they're formed by you have NH3, which is ammonia. So when these hydrogen atoms are replaced by different things, different, things, let's just say things. So for example, methylamine, where you have instead of a hydrogen you would have a methyl group attached to it. So all of these are weak bases. Other examples can include methylamine, sodium okay, codeine, quinine, nicotine. All of these, if you notice, the value of Kb is very small. Okay, so the value of Kb is very small. This again similar to what we learned about in acids. A small Kb value implies it's a weak base. A high Kb value implies it's a strong base. Now we can also obviously, like Ka, we can also have something called as pKb, which is for bases. So pKb is going to be equal to minus log Kb, right? So so for small Kb values, which is a weak base, it'll have a high pKb. And then in case of strong bases, you will have a low pKb. So I think the important thing from like the previous one and this video is more related to the numerical. So definitely check those out, because I feel like the more you solve them, the more easier it is for you to understand how to, basically solve them, I guess. But it's very essential. And the reason this video is important is because you need to know the relationship between the value of Kb and pKb in relation to the strength of a base. Also, definitely check out the video related to the ionization of weak acids, because I feel like we did a more detailed we had a more detailed conversation about the ionization of weak acids. So in the next couple of videos, what we're going to do is we're going to solve the example problems. I did notice there was a small error in one of them according to your textbook. I definitely got a slightly different answer, so definitely check it out.